Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room. This team of specialists is monitoring systems on the space station and working with the Expedition 57 crew members as they move through their Friday afternoon on orbit. And for the first time in almost 2 months, these teams are working with 6 astronauts and cosmonauts in space as 3 new crew members arrived at the station early this week. Right now, they're all getting ready for the arrival of a new supply ship that's due at the door on Saturday.
And liftoff. We have liftoff of Anne McClain, David St. Jacques, and Oleg Kononenko to the International Space Station.
Welcome to Space to Ground. I'm Gary Jordan. 3 new crew members are now living and working on the International Space Station. Anne McClain of NASA, David St. Jacques of the Canadian Space Agency, and Oleg Kononenko of Roscosmos arrived at the station on Monday and received a warm welcome from their crewmates already on board. The trio's journey from launch to docking lasted just 6 hours and 2 minutes and included 4 laps around the Earth. That's faster than your average transatlantic flight from JFK to Heathrow. The new crew spent some time getting used to their space legs and aiding their crewmates on various tasks where they were able. And there will be much for the new crew to do, including new science that's on its way to the orbiting laboratory. The SpaceX Dragon lifted off from Florida this week with more than 5,600 pounds of cargo, nearly 2,300 pounds of which includes new scientific experiments that will be looking at things like observing Earth's forests, transferring liquid methane fuel, and protein crystal growth. The craft will be arriving early this weekend, so check out nasa.gov/NTV for the latest schedule and to tune in live. Astro ETAC asks, how do astronauts spend holidays on the space station? Will they have a chance to call their families, celebrate with their crewmates, and even share a meal? Space station crew members are allotted a small amount of mass on cargo vehicles for some fun holiday items of their choosing. Anne McClain even chose an elf on the shelf as a zero-G indicator for her launch. Some mass is also set aside for special holiday food like candy yams, potatoes au gratin, and some shortbread cookies. These items will be arriving soon on the SpaceX Dragon, as well as some cranberry sauce and a fruitcake for the spacefarers to share with one another. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
As Gary mentioned, NASA will provide live coverage of tomorrow's arrival of the Dragon cargo ship. That'll be on NASA TV and online at nasa.gov. We begin at 3:30 Central Time Saturday morning for coverage of the rendezvous of Dragon with the space station and capture of the vehicle with Canadarm2. Our coverage then resumes at 6:30 a.m. Houston time tomorrow as the station crew and the ground teams work together to install the Dragon vehicle to the Earth-facing docking port of the Harmony module. This Dragon cargo ship is carrying more than 5,600 pounds of supplies, equipment, and scientific research to the station. And that includes a test of technology that might make refueling of space vehicles and satellites in orbit a routine thing. NASA astronaut Anne McClain will be one of the station crew members involved with unpacking the supplies from that new Dragon ship and setting up some of the experiments it's delivering. McClain has been training for her first mission for more than 2 years now. She says that her training benefited from something she learned about achieving goals from her time playing rugby.
So the first time I played rugby, I was actually 18. It was the year before I went to West Point, and I was walking across the Gonzaga University campus, and I saw a group of people playing a sport that was unlike anything I'd seen. There was a lot of tackling. I couldn't figure out what was going on. And one of them asked me if I was interested in trying it out, and the very next day I started in my first game of rugby. I played throughout my time at West Point, and then when I was a Marshall Scholar, I was fortunate to study postgraduate in England, and there I started playing at a higher level. In 2004, I was selected to the U.S. national team. I was fortunate to play a lot of rugby, and then I also coached a little bit right before I went to test pilot school. My last weekend playing rugby was the weekend prior to finding out I became an astronaut. So rugby has surprisingly helped me a lot as an astronaut, and when I'm training in the spacesuit in the EMU and we're working in our large pool, the neutral buoyancy lab, underwater, we're under there for 6 hours at a time, and you really work yourself to physical and mental exhaustion. The only other time that I've hit that point of exhaustion is the 60th minute of a rugby match. When your body gets that physically tired, you can't mentally give up. You actually have to think about things more deliberately, with more clarity, because you're more prone to mistakes. And it's the people that can overcome that physical and keep going with the clarity of mind that win both rugby matches and that find themselves successful training in the spacesuit. I am Anne McClain, and I am an astronaut.
Anne McClain and her 5 crewmates on the International Space Station each made the trip to orbit on a Soyuz spacecraft. But the day is coming when some station crew members will make the trip to and from orbit in different vehicles. NASA's Commercial Crew Program is working with 2 companies that are moving right along in getting their own rockets and crew vehicles ready to join the fleet.
I am not a geeky person, and I don't really love software all the time, but actually seeing automated software, not only on the spacecraft, but on the rocket come together, it's really cool.
Boeing is flying a ULA Atlas V rocket, and they will have their CST-100, or the Starliner, as they call it, sitting on top of that. For the SpaceX side, we've got the Falcon 9 rocket, which is now the Block 5, and some of you may be hearing about that, as well as a modified Dragon capsule on top.
When you step into even just a demonstration of what their capsule looks like, it's like, whoa, you know, this is huge. It has this beautiful feel and touch to it. It's very sleek.
We really designed, for the first time in 30 years, how does a human interface with a spacecraft? And a lot has happened in 30 years. I mean, we see cars that autonomously drive around the road. How do I create that interface to allow the human to be involved, but at the same time a passenger and not too involved? How do we make it easier for someone to become an astronaut?
Folks all over the world are going to be watching this because we're integrating new technology. It's going to make these spacecraft better and smarter and paving the way for the future.
Whether in space or on the ground, all human beings have trillions of microorganisms that live on and inside our bodies, and many are essential to human health. Because of that, one study on the International Space Station is looking into how these microorganisms change due to spaceflight, and how that change can affect our body's internal systems. tool that has helped guide sailors across oceans for centuries is being tested aboard the International Space Station these days. It's an experiment looking at the use of a handheld sextant as a potential emergency navigation tool to guide spacecraft across the cosmos.
Lines up a known star and a prominent landmark, and feeding his readings into the computer, gets his position back from the machine.
John's pointing right now at the sextant and a telescope, which are our navigation means to get home.
A good portion of the research being done on board the International Space Station is intended to support future trips out beyond Earth orbit, to the Moon and Mars and out into the solar system. The people responsible for those projects are just as much heroes as are the astronauts who get to go to space.
So you want to go to Mars. What does it take to be a NASA hero? Meet the heroes behind the scenes who make deep space exploration possible. People often think of astronauts as heroes, and they are. And they will be the first ones to tell you that there are many other people who make space missions successful. On Earth, there's ground support, the folks responsible for launch and landing. Heroes work in mission control and keep a watchful eye on the astronauts and spacecraft 24/7. Heroes design, test, build, and fly the rockets and spacecraft that take astronauts off our planet. And there are heroes who make spacesuits, habitats, and equipment for the astronauts to live and work on the Moon and Mars. Human spaceflight is possible because of the heroes on the ground and behind the scenes who build the technology and systems needed to send astronauts into the solar system. Will you be a NASA hero? For more information, visit this NASA website.
Along with doing hands-on science in the International Space Station's laboratories, the crew members have been talking directly with students on the ground to share the experience. Some of the astronauts have been making fun instructional videos in zero-G. In this installment of the STEMonstration series, Scott Tingle demonstrates the orbit of the spacecraft and offers viewers the chance to participate.
Hello, my name is Scott Tingle, and I'm living and working on board the International Space Station. You know, I love my views from the cupola. It's our orbiting altitude of around 400 kilometers or 250 miles above the Earth's surface that gives us these unique perspectives. Let's explore how our ISS orbits work. Come on. First, I should explain, orbits are elliptical or oval in shape, with some being almost circular. Planets, comets, and moons have elliptical orbits. Spacecraft orbiting Earth, like the space station, are placed into a nearly circular orbit to keep a consistent altitude as they travel around the planet. Let's take a look at the Earth. It has a radius of 6,378 kilometers, and the station orbits about 400 kilometers above the surface at 8 kilometers per second. That's 17,500 miles per hour. See if you can use these values to calculate how far, how long we travel in one orbit around the Earth. All of this information and more activities related to orbits are available in the accompanying lesson plan at nasa.gov/STEM on station.
Answers coming in.
4, 3, 2, 1.
The answers to the questions, by the way, are approximately 42,600 kilometers and 90 minutes. And due to our altitude on orbit, we have our very unique and awesome view of the Earth. Thanks for exploring with me today. I'm going to send you back to Earth now so you can start your challenge on orbits. See you again soon.
A thing like demonstrations is a high-profile way that astronauts use their time in space to connect with people on Earth. But resourceful astronauts have found other ways to connect their time in space to life on the planet. Recently, one station crew member who was watching a natural disaster unfold on Earth right below him found a way to help.
The first pictures now coming in from Puerto Rico after taking a direct hit. Hurricane Maria slamming into the island. One official saying the island is destroyed.
Hours with winds and rain, and didn't stop.
Power lines are down. Streets are impassable. Many roads are flooded.
High winds uprooting trees, overturning cars, and turning buildings into piles of twisted metal.
It is something that will change Puerto Rico forever.
We had no water, no food, no gasoline, no communication at all.
Not knowing where my next meal will come from, it hasn't been easy.
After Hurricane Maria, everything was gray, all the plants were dead. Hurricane Maria took the color away from us.
I am sure that these children will not be the same. They will not be the same. They are still struggling and trying to recover from this.
My name is Joe Acaba. I'm a NASA astronaut of Puerto Rican descent. I was about a week into my mission on the International Space Station. Hurricane Maria was forming up, and from there, if you looked out the window, Maria took up a big chunk of what we could see. It was going to cover the entire island. After the hurricane, their power grid was pretty much taken out. You just couldn't see the island anymore. The hurricane, I think, had a huge impact on, the island as a whole, but especially the kids.
Joe Acaba was our hero, and we need something positive. The students need something positive.
We wanted to pull through, forget all that happened, and lift up our spirits and lift off the island.
So I knew I couldn't do much from up on the International Space Station, but I did want to connect with the students to show them that there is hope and that there are people out there that care about them.
NASA has the STEM station, which allows the students and teachers to talk to the astronaut in the space station.
It's making that connection so that maybe, they become more interested and we can inspire them more to study the STEM fields.
So we were able to establish and coordinate with NASA one of these video conferences. Thousands of students from different parts of the island watching the video conference with the space station, talking to Joe.
This is Joe aboard the International Space Station. I have you loud and clear.
How do you compare?
What is the most impressive view?
How did Puerto Rico look? Are astronauts allowed to visit? How often?
What is the minimum number of?
It was awesome because, as soon as it came up, you could hear people clapping, people were excited. So even though I couldn't see them, I could feel them, and that was pretty neat.
It was amazing. He called from the International Space Station to see how Puerto Rico was doing, and that means a lot for us, a lot.
In May of 2018, I was able to go back to the island, my first time since the hurricane. It was a great opportunity to to get out and kind of come full circle with those students, to go and see them in person and, kind of reiterate how important they are, and just to give them a little bit more hope, because there's still a long way to go on the island.
He's a hero for us. Kids love him, and everybody loves him here. Joe Acaba is the role model that we need at this time.
I want to be like him. I want to go far, and I want to be an example for little kids when I'm older.
Not only is the International Space Station a great tool for scientific research and exploration, but for students from Puerto Rico in particular, I think that having that video conference with them, it did provide some hope. It did provide some inspiration. And so it's just one of the benefits that we get from the International Space Station.
In some of our features, you get a chance to see views of Earth captured from 250 miles above as the International Space Station cruises along about 5 miles a second. Well, along with those cameras on the outside of the vehicle, the station has some great picture windows that the human crew members can use. And in the Destiny Laboratory, they have a special piece of hardware that combines art and science.
An intersection of art and science on the station. Presented by Science at NASA. Large and powerful telescopes have delivered stunning images of our galaxy and the universe. A little closer to home, my colleagues have taken some equally stunning photographs of our own planet from the International Space Station. My name is Mario Runco, and I'm an Earth scientist and former Space Shuttle astronaut. After seeing our beautiful home planet from orbit, I wanted to be able to share the experience with everyone. So one of the NASA accomplishments of which I am most proud was helping to spearhead the creation of the WRF, the Window Observational Research Facility on the ISS. My colleagues, Dr. Dean Epler and Dr. Karen Scott, and I envisioned a small facility, about the size of a large refrigerator, that would enhance the capabilities of the large Earth-viewing optical quality window that we were previously successful in getting aboard the station. This vision became reality as the WRF was launched to the station in 2010 on board the STS-131 mission of the Space Shuttle Discovery. The optical quality window and the WRF are a perfect blend of art and science. They allow us to conduct Earth science research and capture amazing high-resolution photographs of the Earth. The window is located in the U.S. Destiny Laboratory module and features the highest quality optics ever flown on a crewed spacecraft. It is 20 inches or 51 centimeters in diameter and includes a non-optical quality retractable pane that protects it when it is not in use, but still allows natural light into the station and provides a great view for the crew. The WRF is capable of housing a variety of sensors within the shirt sleeve environment inside the space station and serve as a testbed for the development of new sensor technology. These sensors can be used to study atmospheric, oceanic, and surface terrain conditions, as well as make environmental health assessments. Observations made from the WRF can provide important data on transient atmospheric and geologic phenomena, such as tropical cyclones and volcanic eruptions. It also helps us to better understand our local solar system environment. The National Laboratory Meteor Investigation allows for spectroscopic analysis of meteors as they enter the Earth's upper atmosphere. The WRF's presence on the space station allows its sensors to image the same location or region multiple times over several days. This allows for observations that can show, for example, how vegetation below may be changing from day to day. Subtle changes detectable by orbital sensors that might be indicative of declining plant health are rarely visible on the ground in their early stages, and often by the time they are, it is too late and crops or even forests may be lost. My colleagues and I are all avid Star Trek fans, and we decided to name the facility WRF after the Honorable Klingon warrior. We designed a mission patch that included Klingon script for the acronym WRF, and even an alternate version with a depiction of an astronaut bearing an uncanny resemblance to Science Officer Spock making observations of the Earth from the WRF. For more of the many wonders that can be observed from Earth orbit, go to nasa.gov/ ISS-Science. For similar out-of-this-world stories, visit science.nasa.gov.
If you'd like to get another look at any of the stories we feature today, check us out on YouTube and Facebook at those addresses right there on the screen. And while you're there, look around and check out some of the other cool stuff you'll find about NASA and America's human spaceflight program. And while you're out on the internet, check out Houston We Have a Podcast. Folks here at NASA talking about their work in all aspects of space exploration. We post new episodes on Fridays, and today, Gary Jordan talks with one of the newest members of the International Space Station crew. Discussion with Anne McClain about her first spaceflight and the path she took that led her to Earth orbit. Go to nasa.gov/podcast to find today's episode and all the previous episodes. And matter of fact, you'll find the full library of all NASA podcasts there, nasa.gov/podcasts. You can also listen to any of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.